Okay, hello everyone, and welcome back. Today we're going to look at point-slope form. Again, we're looking at lines, linear. All right, this is used if you know a point and you know the slope. Okay? Again, the objective to create a point-slope form of an equation. Today's essential question for the homework check: how can we create a linear equation giving a point and a slope? Guys, the point-slope form of an equation, it looks like that, okay? Of a linear equation. It's relatively simple. Again, and we use it if we get one point and we know the slope. And this looks kind of like the formula for a slope we talked about on Friday. Again, what does it stand for? Basically, look at, you know one point. So the x1 and the y1, you plug into the formula. They're numbers. They're known numbers. And then m is the slope. That's another known number. You put it into the formula, into the equation. And then the x and the y is just any other point. So think of the x and y, this red one just sliding up and down. That's the variable. It changes, okay? Just to kind of make sense of it again, it kind of looks like the slope formula as we talked before. Remember the slope formula? We said it was the change in the y over the change in the x. All right, we went y minus another y and x minus another x. Okay, well, we're just going to kind of write it like that because we only know one point. We don't know another point. So then we just, rearrange it. You rearrange it using the algebra that we've talked about before. The x minus x1 on the bottom, just move it to the other side so it's next to the m. And we get the formula that looks like this. That's kind of how you derive the formula, okay? It looks just like the slope formula, basically. Okay, real quick, I can show you guys a slope of 1. It kind of looks like this, all right? Slope of 1. If we move this around, though, a little bit, as an example, we can change the slope. Right? As I change the slope, you see how if the slope is 2, 3, 4, it goes high, high, big, big, big. All right? Or this way, I can flatten it out. Now it's 0.2, 0.3, 0.4, where it's flat. A slope of 1 is sort of right about there. Okay, a slope of 1. You see the 1 in front there? And then the y, we can move this around up and down depending on whatever point we're going to use. There's 6, 6. There's the point right there, 8, 4. All right, so we put 8 right there and 4 right there. And the slope of 1, put it right there. If the slope changed, if it was a half, let's say, then this would be a half in front. All right? All right, just some examples again. Here's a line. We're given a line and we're given a point on that line, 3, 2. Use the triangle again to find the slope, the rise over run. Find another point up here on the grid. And just the rise over run. This is the slope of 3. So you put the 3 in the front. Again, so this says y minus 2 because 2 is the y value, the y coordinate of our point. And this says x minus 3 on the inside of the parentheses because 3 is the x coordinate of the point that we know. Now you can multiply this out. This is showing down here how to change it from point-slope form that we're talking about today into slope-intercept form that we talked about before. You just multiply it out. You distribute that 3 and then add 2 to both sides. Let's look at another example here. This one has a negative slope. It's coming down, down, down. It has a slope of negative 3. All right, and it goes right through the origin, 0, 0. You see that right there? So we can just use 0, 0 for the x1 and the y1. Just put zeros in there. So the equation becomes very simple here. Y equals negative 3x when it goes through the origin. We also talked about the special case where it's a vertical line, which is the slope is undefined. It's a special case, and it's x equals some number. Because straight up and down, this blue line right here always is 1.5. It's always x. X is always 1.5. Up and down. Y changes, but not x. X is always 1.5. So that's the equation of that vertical line. And again, just to revisit y equals mx plus b that we talked about before. Again, that's known as the slope-intercept form of an equation. And later on this week, we're going to talk about standard form. Okay? In fact, we'll talk about it tomorrow. Again, the b value in y equals mx plus b is the y-intercept. And at the y-intercept, x is 0. X is 0 at the y-intercept. So the point is actually like 0b. We could call it that. If we put it into our formula, where the x is 0 and the y is b, all right, if you distribute the m, and then just add b to both sides to bring the b to the other side, we end up with the point, we end up with the slope-intercept form from the point-slope form, okay? All right, guys, you can go ahead and take a look at the homework check, and we'll look at it in class as well. Thanks.